Hi, good afternoon. My name is Usman Shakil, and I work for Amazon Web Services. I'm an enterprise solutions architect, and I work with the media entertainment vertical from companies that are very large enterprise media entertainment companies to small startups. And a few housekeeping items out of the way. This is a 200 level course, so I will be using some abbreviations, some concepts in AWS. And if they don't make sense to you or anything, you have any questions, I'll stick around at the end of the session. Feel free to reach out to me and we can have a chat. And we really highly appreciate your feedback. That's really important to us. So I'll highly appreciate if you could take some time at the end of this session and fill out the brief survey. So the goal of my talk today is to talk about possibilities for media processing workloads on AWS. For both the workloads that are like bursting or hybrid workloads, where you already have, say, an infrastructure in place and you're looking for additional infrastructure resources, or if it is a 100% cloud environment. And I will focus on the scalable side of it, that how do you really make it scalable media processing on AWS? So let's start with a real world example. I know many of you have already, looked at this or know about this or heard it in many talks, but I'm just going to put it here because I think that this is a highly representative example for this particular session, that how Netflix really used the infrastructure flexibility and scalability of AWS and was able to process thousands of titles and 80 terabytes of data in a matter of days, and were able to meet the deadline for the PS3 launch. Great example. So since I work with many of you, and I work with many startups, many enterprise media entertainment companies, as I said, I'm going to put myself into a situation where, say, I am actually a media processing vendor. All right. And the scenario that I have, or the challenge I have is, just imagine that every one of you just picked up your mobile device and started streaming. You send out your stream to me. I process it. First of all, I have to ingest it properly. I store it properly. I process it. And then I deliver it to wherever you like to deliver it. And it's all of a sudden that everybody started streaming, and so it's a very high demand that I see. So this is what I have today. This is my on-prem infrastructure or my setup. I have a bunch of different streams or different input sources that are coming in. So that could include the camera, your mobile device, could be physical media, could be media files, many different formats. From RTMP all the way to HD, SDI, etc. So first of all, I ingest all of these streams. I have maybe a SAN or a NAS set up somewhere on-prem again. I store the files. Then I have a transcode cluster or transcoder workers that actually transcode it. Additional processing is done. And then I store the streams in some other storage area, again on-prem, and then finally I am delivering it. Now all that is orchestrated with the help of a workflow controller that, say, I have either built in-house or used some third party for. But overall scheme of things, this is what my setup looks like. And this is how my typical processing workload looks like. So first of all, there is the steady state where I have the bare minimum, just making sure that we have enough to really take care of the baseline demand of infrastructure. Then I have the hourly peaks where I have some content that I need to transcode or process on an hourly intervals, and then finally this is where you come into play. That all of you started streaming and there is a whole lot of load that is thrown my way. So I need to really figure out what do I do, because turns out I have a pretty big capacity deficit here. And as you can see, this is an hourly timeline, right? From 3 a.m. all the way to 8 p.m. today, this is what I'm going to expect. So in this kind of time frame, what are my options? Unless I really have a scalable infrastructure in place that really kind of moves as my demand curve goes, there's really no way. I can either be wasting a lot of capacity, where say I knew about reInvent and I over-provisioned, and now I'm wasting a lot of capacity. I'm sitting on a lot of infrastructure resources. Or I really disappoint you guys that I don't have enough capacity to process your workloads. So it'd be really nice if I had a way where my infrastructure actually followed this demand curve. And yeah, you guessed it right. That's where the cloud comes into play, right? So AWS has 9 regions that are global, 9 regions, and multiple availability zones. Again, you probably heard this already. We've got 9 regions, we've got multiple availability zones. I really want to talk about the significance of the multiple availability zones within regions, because they really provide you the infrastructure or the capability to create an environment which is highly available while you are within the same region. You're not necessarily burning or extra bandwidth to say across regions, etc. You can really get it done while in the same region with the help of the multiple availability zones. Now, on top of these regions, AWS provides me with not just the infrastructure building blocks like the compute, EC2 compute service, S3, the storage service, EBS, Elastic Block Store, VPC, Virtual Private Cloud, RDS, Relational Database as a Service. But it also provides me more application level utility services like simple queuing service, simple notification service for orchestration purposes, simple workflow, highly scalable DynamoDB, cloud search, etc. And then finally, utility services to really make my job easy, like CloudWatch for monitoring, IAM for identity access management, CloudFormation, Beanstalk for deployment. And the beauty is that all this infrastructure services, as well as the application services, they're all available in the form of APIs that I can really call right from within my applications and able to build, again, highly available and highly scalable applications. So the journey or the story of a media processing guy standing here, I need, first of all, appropriate scaling and utilization that we talked about. So this was my setup, corporate data center on your left, and on your right, the AWS cloud. So Amazon, AWS, provides me a feature called Amazon Machine Image that I can really start with. So first step is that, or the easiest step is that I move my processing over to the cloud. Now, if I move my data over, I could have a lot of data that I need to move over. That may take some time. But first thing, what I can do right out the gate is start a processing job inside of AWS. How do I do that? I use Amazon Machine Image. With the help of, once I've created the Amazon Machine Image, and we'll talk about in a minute, I can spin up Elastic Compute Cloud instances, or EC2 instances. That could be of many different flavors based on the workload that I'm trying to do. And then I can use Elastic Block Store, EBS volumes that are attached, network attached to these EC2 instances, and I can move the input files over, process the job, and then move it back to, again, back to my on-prem and store it. Now, yeah, this is a very, very basic first step where I'm just doing processing in the cloud. Obviously, there are caveats we'll talk about. Now, before we get to moving data into the cloud, let's talk about what really is a machine image, right? And what are the different ways? How do I set up a machine image? So machine image, first of all, Amazon Machine Image, first of all, I can start with a vanilla operating system. I can deploy my code, any application environment that I have set up there, and then I create a custom AMI. I register the AMI, and then I can create as many EC2 instances of whatever type or size with the help of this Amazon Machine Image. So for example, FFmpeg, if you're using that for your processing, You can start with a Windows or Linux base ARMY, and then you can have FFmpeg installed on it. Obviously, the codecs and other licensing, you can deal with that. But just to mention that in most cases, it's pretty seamless to have the licenses moved over. So for example, I'd like to mention Elemental and Sorensen Media. They provide you pre-built ARMYs. They're either available from the Amazon Marketplace, AWS Marketplace, or from the vendor directly, and the licensing works pretty nicely for the cloud. So what are the storage options with EC2? Earlier I mentioned you could use your EBS volumes, which are network attached volumes, but as many of you already know, there is also a direct attached instance volume or storage that is an option, and we call it the ephemeral storage. Now, I don't want to really dig deep into each one of these storage options. Each one's got its, its plus points, its negatives, really depending on your application workload, what you're trying to run. So for example, for ephemeral storage, if it is just for the matter of, say, processing a small job very quickly, well, you could just use the instance attached storage or ephemeral. It's good for sequential type of I/O, but it is, first of all, there is limited storage available. So for large instance types like clusters or high memory 4XL instance types, you'll probably see something like a 3 terabyte storage capacity. Now, what if you have larger content or larger data storage needs that you really need to process? Then you have to look into EBS. Also, it is temporary storage. So if you lose your instance, basically your ephemeral storage is gone. Whereas in the case of EBS, it is network attached, it is persistent, maximum is 1 terabyte. You can attach multiple 1 terabyte volumes to an EC2 instance. Works great for random I/O, and we recently just announced provisioned IOPS and EBS optimized instances that gives you much higher constant I/O performance with the help of that. So all of a sudden you see that many different workloads that weren't really possible on the cloud because of, say, these storage limitations or I/O limitations, all of a sudden are available now. So we talked about EC2, moving your processing over, storage types that are available, how you create your ARMY. Now the question is, how do I really get access to the data that I have in my data center, right? And after I process it, how do I move it back to my data center? So first of all, I want to talk about AWS Direct Connect. Again, I don't want to really dig deep into it, but just like to mention it that it is a service which is available to you, allows you the capability to really have a private connectivity between your data center and AWS over a 1 gig or a 10 gig connection. And it's a private line, so you have access to all the bandwidth that you need, and depending on how much bandwidth you need, you could utilize multiple direct connect lines as well. You can also use third-party providers like Aspera. They have a product called Direct2S3 or Aspera On Demand, which actually can do fast file transfers over, and Signiant is another example. Again, these are the things that are covered by the media ingest and storage session in the morning. I don't know, probably many of you already attended it, so I won't really dig deep into it. You can also stop by the booths at the conference hall and to learn more about these products. So the second thing I'm going to need is I need to scale based on my cost and demand. I'm a lean, mean shop, and I don't really want to over-provision or waste the resources. So really, what I do is I can, instead of a single EC2 instance that I just spin up on demand and keep it running whenever things come up and I use it, rather than that, depending on my usage patterns, I can either think about using reserved instances or spot instances where I can really go and bid on the excess capacity that AWS has, hence saving me a lot of money. I can auto-scale my transcoding or my processing cluster so that, again, using multiple availability zones, so that if there is something that went wrong with, say, one of the nodes, another node automatically spins up and takes its place, and my processing just keeps on going uninterrupted. So the third thing I'm going to need is agility and time to market. So really, in this time frame, as I said, what really can I do? If I go talk to my IT guys, it's going to take them a long time to provision, procure the resources, get me the processing infrastructure that I need. But what I'd like to clarify here is there's a bigger point aside from just infrastructure flexibility. It's really the application services, the application level services that you see that AWS brings to the table as well. Like simple queuing service I mentioned, simple notification service, simple workflow service. So what that really helps me achieve is time to market. I can really focus on the core application pieces where I'm just working on the processing piece. And everything else, I could just utilize these different utility services, as I mentioned, like simple workflow service, which can start talking to my workflow controller, say that I have built in-house and runs on my data center, but it is all orchestrated and managed at that top layer, which is managed by AWS Simple Workflow. The beauty there is the simple workflow is really platform agnostic. It doesn't really care what sort of platform I am using behind the scenes. I can use any sort of platform to build these worker nodes that may be running either in my own data center and controlled by, orchestrated by simple workflow, or running in the cloud. So really, that is the benefit that I'm really using to leverage not only the infrastructure that I have in place already, but also the infrastructure that I have access to in AWS. So I talked about cost earlier, spot instances. There is a caveat with spot instances. So for those of you who don't know spot instances, it's really, as I said, the excess capacity that you have the capability to bid on, and you can, say, get an instance of a type. So you can basically bid on whatever price you like on the instance. And if your price is higher, you get access to the instance. Now, if somebody comes along and they outbid you, that instance is gone. You lose that instance. So the question naturally is, okay, what about the processing that was done on that instance? What happens to that now? Well, that's gone. You have to redo it, if you have not stored it in, say, a persistent storage. So I have talked to many customers in the past years while working here at AWS and partners. A couple of different things that I see people using a lot. First of all these different processing jobs are of different sizes. So first thing that is in practice commonly is that you really use a queuing system, like a simple queuing service. You can build a queue, and you can prioritize these jobs based on the size of the job. And so while your larger size jobs can go to reserved instances or your on-demand instances where you have the guarantee that, okay, well, you know what, nobody's going to take that instance away from me and it's running, and I'm pretty much certain that this job will finish, the spot instances are only handling these small jobs. So even these small jobs can, kind of accumulate over time and could end up being a pretty large workload. So at the end of the day, what you gain with this model is, or this design pattern is, that even if you lose a spot instance, you're losing a very small processing job, which you can redo if you have not stored the intermediate processing. The other thing, obviously, you can do, and a lot of people do that, is slicing or chunking. So you have all these jobs, you run a slicing application. Obviously, you have to manage it, you have to write it, and you use some CMS system that basically stores the metadata around these different chunks. And then those chunks are evenly distributed across. So in any case, if you're losing a spot instance, or you're losing an instance or losing a job, all you're losing is that chunk, which you can redo again. The fourth thing that I need is infrastructure scalability. So for infrastructure scalability, AWS gives you a lot of instance types that are really meant to work with many different workloads types. So, for example, we have the M1 standard family, the M2 high memory instance types, the CPU heavy instance types, the M3 standard family, which was just announced, cluster compute instances, and high I/O types of instances. So really, depending on the job that you're trying to run or the workload that you're trying to run, that could have many different variables. So really, you have to look into these 5 variables. Your compute power you're going to need, the memory you're going to need, the local storage that you're going to need, the I/O that you're going to need, and finally, the network. And really, depending on your workload type, you can choose, or you should choose, the type of instance that you're looking for. A point I'd like to make here is that all the different EC2 instance types, except from the micro instance type, you do see that it gives you sort of this guaranteed compute and memory characteristics. And really, it is hard provision. So whatever you provision an instance for, it is yours. And the I/O performance really is based on the network and network characteristics of that instance. So highly useful to profile, the instance performance based on your workload and use the instance type wisely. And another thing that also pays off for highly flexible and highly scalable type of workloads or processing workloads is build the capability in your application really to be able to choose from many different types of instances. So at the end of the day, it is a pretty large pool of instances that you're getting the capacity from. But it is always good to be able to increase that pool, if you will. So from compute side, I think we covered. Let's talk about storage. So far, the choice has been that we use Direct Connect or Spera or other options to really move the content across to the cloud and then back to the data center for after the processing. So in this case, what I like to say is that we can introduce S3, the simple storage service that AWS has, into the picture. So many of you who attended the session in the morning, S3 provides you 11 nines of durability. It's highly available. In terms of performance, it scales, or in terms of storage, it scales infinitely, and performance is scaled behind the scenes for you. So it's a managed service. So you can use, actually, the input from all the different input resources that I talked about. I could use either Direct Connect to go straight to S3, rather than going to an EBS volume. And that is my actual primary storage, because it is providing me the underlying durability that I would need. And once I process the content, then I am putting it back onto S3. And that could work for both the processing worker nodes that are not only in the cloud, but also on-prem, because now I have the Direct Connect in place and I have access to high bandwidth. So suddenly I have this use case where my storage is always going to be in the cloud, and wherever, regardless of wherever the processing happens, the input and output could go onto S3. Another point I'd like to make about scalable storage is the recent release of S3 and Glacier Integration. So S3 has a feature of object lifecycle, where you can define the actual lifecycle of an object in terms of days, how many days you want to keep that object in S3. Glacier, on the other hand, is a highly is an archival service, so really cheap proposition in terms of storage. Gives you the same durability capabilities as S3. The only caveat is that the retrieval time is from 3 to 5 hours. So for many workloads, well, that's not going to work because, hey, I need this particular piece of content to be processed right now, right away. I can't wait 3 to 5 hours. So you can really set these policies in place in terms of object life cycles when your content moves into S3 Glacier automatically. So it really is sort of like an HSM system behind the scenes that is built for you. Another thing to note here is there is one single API that you are dealing with. So my processing nodes that I have on, say, that were talking to S3 in terms of the storage for the input and output, they still keep on talking to S3. It does not matter where the content lives, because I am going to request the content from the same S3 API. Doesn't matter if it's in an S3 bucket or it's in Glacier. So I don't have to call multiple different APIs to say retrieve this content, which is the key piece, that you don't have to build this additional complexity inside of your application. A lot of you ask me, what if I want to use S3 as a file system? Well, S3 is really built for storing your static files. It's basically a service for storage, simple storage service. It is not meant to be a file system, so it does not handle the workloads that, say, require a real file system, because it's access to the storage, to the content via the API. You will see there are certain API, there is a time to first byte that you will experience there. There are many third-party providers, many of them here at reInvent. I recommend you go talk to them as well to see what each one of them has to offer. First one was S3FS, Fuse-based file system. The newer versions are actually giving you a cached volume as well, where basically the first time they're bringing in the content from S3 into a cached volume, and then the rest of the stuff, while you're processing the data in that cached volume, is brought in behind the scenes. Similar cases for Twin Strata and Attunity Cloud Beam. That's a new product that's coming up. Shared file systems. So AWS provides you ephemeral storage, high I/O instance types, EBS volumes. You can certainly build a shared file system on top of AWS. We've seen Gluster. Gluster is available as an AMI. So you can use, say, either multiple EC2 instance nodes and create a Gluster file system, or you could use multiple EBS volumes with multiple EC2 instances. So really, we're talking about distributing the system even further to take it beyond the limits of, say, one single EC2 instance, if you will. And all your processing nodes can then start talking to these shared file system. One thing I like to mention here is a pretty nifty tool, S3 Sync, that works pretty nicely between S3 and your file system, that be EBS or any shared file system. It basically takes all the dirty bits from S3 anytime there's content changed and updates it in your file system. All right, number 5. I want to make sure that there is no lock-in. This is a small blip in my everyday job, and with all of you streaming here. So I want to make sure that I'm not really spending a lot of money on pre-buying the infrastructure or really locking into into a vendor. Many of you, as you already know, that AWS provides you the pay-as-you-go model for all the infrastructure as a service services. Now, one service in particular I like to point out here is the CDN. As many of you tell us that for the CDNs, there is a lot of contracts, lock-in in the market, and what CloudFront, the Amazon CDN provides you is really no lock-in in that. And the beauty about CloudFront is that it's very nicely integrated with S3, works seamlessly. You have, say, your content that is stored in S3, you just create a CloudFront distribution that fronts your S3 bucket, and you are using the CDN. You can also use custom origin with CloudFront, basically where, say, you have a delivery node like a streaming node or any other custom origin which is running in your own data center or on an EC2 instance, and you could deliver the content with the help of CloudFront directly to your users. Number 6, I want to make sure that my infrastructure environment that I set up is secure. And I am actually giving another presentation on addressing security workflows or media workflows, security on AWS. Highly recommend you guys attend that if you're interested. But the point I want to make across for this is that AWS really is a shared responsibility model. So everything from the dirt of the data center all the way up to the hypervisor layer that includes the physical security of the facilities, the physical infrastructure security, the network infrastructure security, all the personnel who are managing this, and even the hypervisor patching of the hardware, the underlying hardware, and any hypervisor vulnerabilities, etc., all that is AWS's responsibility. So all of a sudden, being this media processor, standing here again, I do not have this responsibility on my shoulders to go make sure that I, pass all these audits for the infrastructure security layer. And this is all taken care of for me by AWS. What I need to focus on then is starting from the guest operating system to the application layer. And AWS provides me all the tool set in terms of the virtual firewalls, ingress, egress filters, network configurations, etc., that I can really set up a pretty secure environment with. Now, AWS also gives me the capability or information about the underlying security controls that they are taking care of, and they are making sure that they're not only, first of all, managing these industry standard audits and compliances, but they also provide me detailed information or reports around these audits if needed for my application compliance. So just to name a few, I'm not going to go through the whole list. AWS is SAS-70 SOC 1 audited, ISO 27001 certified, and the most relevant to probably all of you guys here, Motion Pictures Association of America Best Practices Compliance. Again, I'll talk quite a bit in detail in the next session later this afternoon, and I highly recommend if you're interested, check that out. A lot of customers, thousands of customers, I would say, are running really secure critical applications on AWS that are SOX compliant, HIPAA compliant, PCI compliant applications. Last but not least, I want to talk about the concept of content access and not really content copies. This is a key concept. So first of all, with the growing AWS ecosystem of partners and vendors that are providing a lot of services, plug-and-play type of services on AWS, this becomes really handy. So for example, for transcoding, you can look into Zencoder, encoding.com, Elemental, Sorensen Media. Many of those are available either as SaaS models or, as I mentioned earlier, as EC2 AMIs that you can spin up and start your processing. On the media server side, Adobe Flash Media Server, Windows, IIS, Wowza, etc., they're all available. On the DRM side, if you're looking into, say, doing DRM processing, by DRM, Microsoft PlayReady, Adobe Access, they're all available on AWS. And when I say available, really as a SaaS model, or you can spin up an AMI from the marketplace or from the vendor directly. So all of a sudden, what we see things going is basically cloud becomes a content hub. So I am processing today for many different devices. Going back to the real world example, Netflix's example we talked about, that all of a sudden a new device comes in, what do I do now? Do I move every single thing from my on-prem data center into the cloud to get access or really benefit from this flexible infrastructure or scalable infrastructure? Or if I have everything there, all I need to do is just process. And it is available for, say, the new awesome device that's out. Another thing is that if I'm trying to give access, or basically I have, say, as a media processor, I am working with many other vendors, many other distributors, that could be, say, doing either processing of my content or further distributing my content. So what do? Do I really transfer all these large files to them? Or could it be just access, that I give access to them because they happen to be on the cloud? And a great analogy there is, being from Seattle, is Boeing. They don't really ship fuselages and the large aircraft bodies cross country. They have vendors coming in, actually doing things on them and assemble an aircraft. So the same sort of thing works here, that all these large data files, when the content transfer is really the key, or it's the pain point, you want to do that as less as possible. And you want to use a storage solution which is highly scalable and is really close to a scalable processing or a compute that you can benefit from. And then in the end, it just becomes a matter of accessing or providing the access to the content and not really transferring the bits. All right, great. So I think doing all this, I was able to handle the load that you guys throw at me. So some of the lessons, what did we learn from here? First of all, I didn't move everything in a first step, or I didn't forklift everything and moved it over to the cloud or AWS. Rather, I moved it in steps. I crawled before I walked or ran. I started with a small single processing node on demand, and then I created a transcoding farm, auto-scaled in multiple availability zones, leveraged the application services like simple workflow, simple queuing service, simple notification service to orchestrate the entire workflow, used highly scalable storage like S3, as I mentioned, used Glacier for my cost perspective. And in the end, it really became a matter of content access. As I said, the key point here, that once I have everything in the cloud, there are many different avenues from there. Some other sources here. There are a few reInvent sessions that I highly recommend you guys checking out, especially the Netflix transcoding transformation, very relevant to this session. I will be addressing media security later on this afternoon. Highly recommend if you're interested in the security topic specific to media to come check it out. Media ingest and storage solutions in AWS was the session in the morning that Joe presented. And Mark later on will be presenting the CloudFront session for media delivery. There's a lot of documentation available on AWS from AWS Architecture Center that talks about many different use cases that people have built or you can build best practices around. There are white papers that you can check out. And then finally, the AWS Security Center that talks about the different security controls or feature set if you are interested. Thank you very much for the time. Really appreciate you guys joining us, and I will highly appreciate if you can take a few moments of your time and fill out the survey. And as I said, I'll be hanging out here for a few minutes. If you have any questions, drop by and we can chat. Thank you.